Hey everybody, and welcome to iFreaks. This week on our panel, we have Mike Holt.
Hello, everyone.
Jaim Zuber.
Hey, everybody.
I'm Andrew Madsen. And this week we have a guest. Our guest is Donny Wals. Donny, do you want to introduce yourself?
Yeah, sure. So my name is Donny. iOS developer for Disney streaming services. And it's currently nighttime for me, so that's pretty cool. Excited to be on the podcast.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code devchat at Sentry.io to get 2 months free on Sentry's small plan. That's code devchat at Sentry.io.
Thanks. So we thought we would talk to you a little bit about a subject that you actually spoke on at Try Swift in Tokyo earlier this year, and I was lucky enough to be there speaking as well, and heard your talk and also agreed with it, which was great. Why don't you tell us what that talk's about?
Sure. So my talk was about core data. It was titled In Defense of Core Data because core data has a horrible reputation, especially with developers that have tried it like 5, 6, 7 years ago, or new developers who, Google core data and find out that anything except core data should be better for them to use. And I kind of disagree with that sentiment. So in my talk, I made the case that Apple made tons of changes to core data in the past couple of years. It has improved a lot. It's become a lot easier to use. And my goal in the talk was really to just convince people to give it another go using some simple examples, some setup code. And I think it was pretty effective. I got a lot of responses from people that either gave core data another try or decided that core data wasn't as bad as they thought it was. So that was really cool.
Well, so before we defend it, let's talk about why it needs defending. What are some things that people call out as, bad things about core data?
So some of the arguments I've had from people is that it's just too complex for basically anything. People say that it has bad performance, or that there's so much boilerplate involved that it's unusable, or that it's really impossible to do any multi-threading with it, to have multiple contexts going on, that it's crashing all the time. Really just those kinds of things that are not necessarily completely false. It's just, it's easy to run into some pitfalls if you don't take the time to understand the framework.
Yeah, I think the one I hear come up the most frequently is the multi-threading thing. And for context, I started writing core data in 2005, which is when it came out in macOS 10.4. And I've used it in almost every app I've ever shipped since then. So, it's going on 15 years of me using it. And I feel like I know a lot about it. But I think one of the things that you kind of mentioned this, but that one of the things that people miss is that it has changed a lot. And it's funny because a lot of the people that don't like it came in, after it had changed a lot since I started using it. Like when I started using it, there was no support for migrations, period. If you wanted to do a migration, you were on your own. There was no core data API for it whatsoever. And there was no support for multi-threading beyond just the rule of, hey, don't, create separate managed object contexts and confine them to their own threads. And this is before GCD, so it wasn't even queues. It was just make sure you don't use this on multiple threads kind of thing. This is part of the thrust of your talk, which is, if you tried core data 6, 7, 8 years ago, a lot has changed since then, and it's better now. Walk us through a few of the things that have gotten better in the last, I think iOS 10 was really the last major update, with lots of new stuff, but how's it better now?
So yeah, iOS 10 was a huge milestone. They introduced the NSPersistentContainer there. So one big thing is that instead of having 20, maybe 30 lines of setup code for your core data stack, it's not just a couple of lines for a simple stack. If you want to do something more complex or custom, it's a couple more lines. So within like 10 lines of code, you can have a pretty custom, tailor-made core data stack that has everything you need. And then in terms of the multi-threading is, instead of having to manage, like in the past, you would have to make your root context, basically, which is your context that would be on the main thread, the one that you would use for all your UI work. And below that, you could maybe balance a couple of child contexts, and they would have this parent-child relationship. When something changed in the child, you would have to merge it into the parent, which, it's a lot of steps. So obviously a lot of mistakes were made there. And since iOS 10 with NSPersistentContainer, all you need to do now is just ask the persistent container for a new child context or a new background context, or even just tell it to perform work in the background and it will use its own context. And you don't need to worry about like, how does this merge back into the parent, because the persistent container does all that for you. And you also mentioned migrations just now. And when I just started doing core data, I had to do these migrations and be very mindful of them. But ever since, I believe it's also iOS 10, I can't remember the last time I had to do a migration, because core data can just infer everything on its own as long as the changes are simple enough. And yeah, I think that really kind of sums up some of the more significant, easy to notice changes. There's a lot more changes under the hood, but I think these two are good to start with, just the amount of boilerplate and the multi-threading. Oh, and actually also the migrations. So 3 things.
Yeah, I want to dig in a little bit on the migrations thing. This is something I actually didn't realize had changed. I don't feel like Apple did a super great job of advertising that they had made a change there. The change is actually not that core data can now infer migrations. It's been able to do that for a long time using something called lightweight migration. The change now is that you don't have to create a separate model version. You can just update your model directly, the same version you've always been using, without having to create a new version and set it as the current one. And the reason that works now is because core data actually stores a compiled down version of your model in the store that it creates when it saves, to the database. So when it loads up an old store, it knows what the model schema is without you including that in your app. But that is pretty nice, because it means for simple changes and incremental changes, you just don't even have to think about migration anymore. It just kind of is almost like it's invisible. It just works.
So what version of iOS or Mac OS did this happen?
iOS 10, which coincides with Mac OS 10.12, I think.
Okay. And like, what are some examples of some lightweight migrations that you don't have to deal with? Any changes?
So one simple one would be adding a property, for instance, either one that's optional or a non-optional one that has a default value. Like the path to get there has to be really simple. So if you would add a non-optional property without a default value, core data would not be able to, migrate on its own, because it wouldn't know what to use as default value for that field. So like adding some simple Boolean that defaults to false, you don't need to make a new version for that. Core data will do it for you. Also just removing properties, for instance, it's also very simple. I think renaming would cause it some trouble. Yeah, for renaming, you would need to step in and at least make a version, probably a migration, but.
Yeah, so that's actually not true. You can rename either an entity or a property, and it's fine. Where you'll get into trouble is if you change enough that core data can't figure out what renamed. Like if you rename an entity and change all of its properties, it's going to be hard for core data to figure out that they're the same thing. But if you for simple renames, you're fine. If you search the documentation for lightweight migration, you'll actually find a list of everything that you can do. Donny pretty much covered them, but basically the changes all make, the things that you're allowed to do all make sense. There are things that you could do that, core data can easily tell how to migrate to. So adding a new attribute, as long as it has a default value or is optional. Removing an attribute, it knows it should just delete that data. If you have a non-optional attribute that becomes optional, well, that's fine. If you have an optional attribute that becomes non-optional and you define a default value, then core data knows what to do with that. You can do a rename. There are a few other things like around relationships and adding new entities and such. But there are also more complex changes that you cannot expect core data to just figure out for you. So
I hadn't actually tried the rename thing. It's pretty cool that it can infer that. I was not expecting that.
I actually just looked up the documentation and I had kind of forgotten about this, but you actually set a rename identifier.
Okay.
So you tell it, you give it a sort of a canonical name that is the name between versions. That's how it works.
So it's pretty much automatic.
Yeah.
Still cool though. Like
right. You have to add that rename identifier, but you still only have to edit your model. You're not having to create a migration map or anything like that.
Really cool. Yeah. So that is one of the changes that I really do love, is that you have to worry much less about changing or incrementally building out your data model as your app grows.
Okay, is this functionality just built right in? Like, do we have to do anything to enable this?
Just make sure you target iOS 10 and above.
Very cool. What are some examples of migrations that will not work? Like, what's the line where you have to do it yourself?
So one migration that I'm always very wary of is like adding a new value that just doesn't have a default property, but you do need it to be there. Because that one, obviously, core data cannot magically materialize values that make sense. So that is definitely the biggest one for me that I would say it's just impossible to do. And yeah, if you want to like change all your relationships, like move everything everywhere and just refactor your whole data model, you better be prepared to write a migration for that, because core data is, while very good at inferring everything and understanding the migration path, it's also quite limited.
Yeah, so I think another example would be splitting one entity into two, which you sometimes want to do. Can't really do that. You can't merge. You couldn't merge two entities into one. Anything that requires you to do transformation on the data itself. So, for example, you have a name or a first name and last name field, and you want to combine those into a single name field, or vice versa. You can do that with core data migration, but it can't figure that out for you. So you can't use the automatic migration if you're doing things that transform the data that was stored in the old store. I feel like we could do a whole show about core data migration, because there are actually 3 levels. There's automatic migration. There's using a migration map, which is still just a file that you create. And then there's doing fully custom migration, where you subclass a bunch of classes that are part of the migration machinery and write your own code to do the migration.
Yeah, for sure. And also like strategies for how to migrate safely or properly. I haven't done much of that in core data, but I remember from doing SQL migrations is that doing stuff in the wrong order, if you're going to go the manual route, can be pretty bad. You start deleting stuff before everything copied it over, or, just doing things in the wrong order. So yeah, definitely a topic that can be talked about for a long time.
Let's talk about some of the other changes you mentioned. And I think maybe the biggest one is the addition of NSPersistentContainer. So what does that buy you?
So it buys a couple of things. One of them is just easy creation of your stack. You just tell it, basically in its most basic form, you just tell it like, this is the name of my, my SQLite file or my Xcode data model file. and just tell it to load the persistent stores. You get a call like closure, and in there, everything is done for you already. So at that point, you're 100% sure that your store is loaded and ready to go. It also gives you a nice managed object context called the view context, which is a context that does all of its work on the main queue, or the main thread. So that one is used for like getting objects into your UI. If you would do a query for managed objects that you want to show in a table view, maybe combine that with NSFetchedResultsController, you would definitely want to use the view context for that. So the NSPersistentContainer also buys you easy creation of background or child contexts. So you can quickly get a reference to a managed object context that does all of the work that it's supposed to do on the background. And then the persistent container will take care of merging the changes you make there back into the view context. So that's really nice. And the third thing that I think is really nice about it is that it also gives you a simple perform on a background method, which any code you pass in there, it will run on a managed object context in the background. So you don't even have to worry about keeping track of the context, or you don't even have to worry about making sure everything's on the correct thread, because all the code you pass into this perform in the background closure will be performed on the correct thread. So it just takes away a lot of your headaches and gives you some cool features.
I'm trying not to talk too much. Core data is kind of my thing. So but anyway, I'm not trying to crowd you out, Mike and Jaim. I think that what you mentioned around multi-threading is really, it seems subtle, but it actually makes multi-threading even easier in core data. I know that one of the things that has kind of come up in the community before this change is like, what's the best architecture for multiple managed object contexts? So should I use parent-child context? Should I use sibling managed object context? Should they share a persistent store coordinator, or should they have their own? And there are trade-offs involved in each of those. And I'm not saying that those trade-offs don't still exist, or that there's not still room potentially for different architectures in rare cases, but NSPersistentContainer kind of abstracts that all away, and you just don't have to worry about it. You get the view context, the main thread context, free. If you want to create new background context, there's just a function to do that. And you don't even really need to do that. If you just want to do some simple work on the background, you use perform in background, and there you go. So it frees you up from a lot of that thinking about how to structure your core data stack, especially when you are doing multi-threading with multiple contexts, and means you're writing less code that's bug prone, but there's also just less cognitive overhead. So I think that's actually pretty significant.
Yeah, for sure. I've also found though that because it becomes easier when we started using core data in the team that I work in, because it was so easy, people were not really aware of these threading limitations. So it was very easy to skip the bounds of threads and pass objects into other places. So we did end up kind of having to make sure that we didn't do that too much. But yeah, all in all, once you realize that, and even when you turn on the strict thread checking in Xcode, you have like an option in your schema. I don't know the argument on the top of my head, but it basically will crash your app anytime you encounter a threading violation in core data. So it's really nice. Like, even though it's a lot easier, you can still safeguard against mistakes using that argument. So yeah, we use that a lot to make sure that we don't accidentally cross thread boundaries. Because as you may know, core data is supposed to kind of crash or act weird, but it will often not do that until you're shipping your app or, shipping beta releases.
Yeah, unfortunately, it's not as strict as you would want it to be when you make a mistake. Sometimes it just is flaky. Similar to how if you use UIKit in the background, you don't necessarily get a great, crash or error message or anything.
Yeah, sometimes you just want the thing to like crash on you super hard. Be like, hey, you're doing this completely wrong. Just boom, here's a crash. Instead of just, yeah, like you said, it'll be flaky and act weird.
That makes a lot of sense. So within the past 3 or 4 months, I got a chance to hack on a core data project pretty heavily. And before that, I was on team, just you don't need core data for most apps. And I'll even stand by that. Most of the apps that I've worked with just didn't need it. But this app used it a little bit, and I got a chance to dig in to actually see how it works, and I ended up liking it. Like anytime something crashed, it was my fault. I had done something wrong. So I figured that out, and came to appreciate the core data way of doing things, and it's pretty elegant, and I enjoyed it. But I think one of the things that cause people to run away from it is they don't really understand how to set up the patterns. So maybe if you could, talk about, let's say you're doing, you've got your, UI and you're doing a network request that comes back on a background thread. How do you get that data to your UI if you can't go just, use the same object across threads? Like how does it work setting that up and getting that all to happen? Can you walk us through that?
Yeah, sure. So in an ideal world, so let's say once you have everything parsed and stored, you're going to put it like in a table view or a collection view, right? So your data comes in on a background thread. You tell the persistent container to perform work in the background, either by getting a background context or using the convenience closure on the persistent container. You process your data, you import it into the data store. And then the persistent container will merge that to the view context. Now, if you want to render stuff from core data, like if you have your fetch request and those results are something you want to have in a table or in a collection view, you can use NSFetchedResultsController, which is a really nice wrapper around a whole mechanism between getting a fetch request, then observing changes in a certain managed object context, like inserts or delete or objects that move in your data set. And it will then tell you like which index paths changed. So you would use that to drive your collection view and tell it what to change. So to summarize, you would get your data on the background thread, process it there, save it, and then use an NSFetchedResultsController to observe a certain predicate that will fetch your data. And because of the persistent container, everything will just magically react to changes in the data store. So your UI will just update using batch updates on a collection view or a table view. Or in, I believe iOS 13 has a sort of a diffable collection data source that FetchedResultsController also supports now. So you can even use the all new APIs with core data.
Okay, is the FetchedResultsController, is that like based on a table view controller, or is that its own thing?
It's its own thing. So what it does is you give it a fetch request with a predicate. A predicate is just a filter for your data set. So let's say you have a list of cool places you want to visit. You could be like, give me all places in some country or whatever. And you get a result set from that. You're probably familiar with that flow of retrieving data. And then if you want that to be like reactive, to react to changes, you would pass that fetch request to a FetchedResultsController, which is just going to observe changes in the managed object context that you pass to it, and then use your fetch request to see like, hey, so this changed, this object is new in the data set, this object moved from index path this to that, and it will just call back with those changes, and you take those changes and you apply them to your own table view or collection view, or really anything else if you want to, but they seem to be really made to cooperate with table views and collection views.
Yeah, so could you have that fetch controller be your table views delegate, for instance?
Not really. You would still have to write some glue code to make them play nice with each other. But it's almost a one-to-one like translation that you would have to.
Yeah, it's for common fetch results controller use cases, I feel like it's more or less like boilerplate, like and one line, like your self-wrote index path gets really simple because you just pull your model object out of the fetch results controller, and it has sort of a corresponding object for index path sort of method. I do want to point out, as the resident Mac developer, that on the Mac we have NSArrayController, which has been core data aware ever since core data came out, and actually is similar to FetchResultsController but significantly more powerful. It's designed for use with Cocoa bindings, but you don't really have to use it with Cocoa bindings, and it does everything that FetchResultsController does and more. Well, except it doesn't do it doesn't cache its data sets, but I've never really needed that in FetchResultsController. I definitely have to say that using FetchResultsController kind of makes the whole core data equation nicer, specifically because it handles my model layer just created some new data after a network fetch. I need to somehow tell the UI to update. It does that part for you.
Yeah, for sure. And especially in iOS 13, I haven't had a chance to play with this bit, but FetchResultsController now also supports the diffable data source. So I don't think currently you have to implement this boilerplate bit where you say take all the insert changes and apply them to the collection view, take all the move changes and apply them, etc. I believe now you can just take the diffable data source thing and just apply it to your collection view and have it update on its own and figure out what goes where, which is really powerful, which makes FetchResultsController even nicer, and also the whole core data experience just that much better than anything else out there, I think.
Okay. Now, just for fun here, I'm curious what you guys think the future of core data is. I want to hear some speculation. I mean, with Swift UI coming in and replacing UIKit, do you think Apple's going to kind of do the same thing with core data?
I doubt it. So they have made a lot of changes to core data in the last couple of years, making it much more powerful. This year they added CloudKit sync again. Hopefully this time they got it exactly right and it's going to be amazing. So I think it's going to move more towards a thing where it's going to be a bit like what maybe Firebase does or Realm, where you can have a local store and one in the cloud, or only local or only cloud. And I can definitely see it becoming more Swifty or more Swift friendly, but I'm not sure if they're ever going to completely move away from core data, but I think there's a lot more changes in the pipeline that we'll see in the next couple of years, especially to make it play nice with Swift UI, like some Swift UI version of FetchResultsController. That would be great.
Yeah, well, it still seems a little too tied to Objective-C still, and Swift UI seems to be completely moving away from anything even remotely related to Objective-C, and so that's why I think core data, like you were saying, may move a little bit more in that direction, farther away from Objective-C and those ties to that, and more towards Swift, and maybe even a little bit like Swift UI. I don't know.
Yeah, for sure. My argument would normally be Apple uses core data everywhere in their own stuff, so they probably don't want to replace it. But they also use UIKit everywhere, and they're starting to replace that. So what's to stop them from slowly doing the same with core data at some point?
Yeah, it's a little hard to know what Apple's thinking unless you're inside Apple. I do think it's not that hard to sort of shim over core data so that it works with Combine. And probably I haven't dug into Swift UI enough to really have an intuition for it, but core data implements these things in a different way than you might do in Swift, but it actually has pretty rich support for key value observing and notifications, et cetera, the kind of stuff that you could build on top of to make to do reactive UI with core data. That said, I think Mike, you're right that core data is a Objective-C framework through and through at its core. And in fact, if you wanted to write something that was exactly equivalent functionally that worked the exact same way as core data, you couldn't do that in Swift right now because it makes such heavy use of the Objective-C runtime and runtime reflection and just stuff that Swift can't do yet. So they would have to rethink their approach if they were going to write it for Swift. It'll be interesting to see. Donny, I thought there are some other changes that I don't remember if you mentioned. I'm not actually sure if you mentioned them in your talk or not, but one of those that comes to mind for me that was a change in iOS 10 is the automatic code generation stuff in Xcode, in the Xcode model editor. Can you talk a little bit about that?
Yeah, sure. I briefly did mention that in my talk as well. So basically what you would have to do in the past, like pre-iOS 10, is first you would write, like at least for me, the process was to first write my NS managed object subclass. So go in, write all the properties, annotate them with NS managed, set up all the relationships there, and then make the same model in the core data model editor. So you would do everything twice. And currently, what you can do is you can tell Xcode to either generate an extension on an object, so it will implement all the core data stuff in an extension, or you can tell it to just generate the whole thing for you. So it'll just make the whole model file with all the relationships, all the types, and you don't have to worry about that yourself. So you only have to do the work once, which is really nice. I did find that in some cases, you end up with optionals in places where you would maybe not want them or expect them. So it's not always perfect, but it's definitely a time saver and a great starting point to begin at, and then, adopt your code as needed.
Yeah, optionals are one place where there's definitely still a mismatch in core data, and it's because the core data concept of an optional is not the same as the Swift concept of an optional. I'm not exactly sure if there's really any great way to fix that.
Well, I'm not sure there is. Like, you can make everything optional on your managed object, but that doesn't mean that core data is going to accept it when storing your entity. So you could be like, oh, this thing is optional, you don't have to have it. But then when you call save on your managed object context, then basically, like, I think it's probably somewhere at the SQLite level, maybe, or possibly in the core data framework, where it's like, no, I'm not going to save this because you're still missing some values, which can be very off-putting if you see an optional in your code and suddenly it's not that optional, which is also why sometimes I'm not very happy with the code generation, because it makes things optional that are not really optional, which can be very confusing.
Yeah, you're right. And the reverse is also true. If you have something that is non-optional, like if you make it non-optional in the core data model editor or even in Swift, in the subclass in Swift, it actually technically can be nil as long as as far as core data is concerned. It's fine if it's nil up until it's saved. That's when it needs to be non-nil. So there's just this difficulty in bridging the two concepts.
Yeah, I've definitely run into cases where, especially pre-code generation, I would write my own model, make something non-optional, but then accidentally make it optional in the Xcode model editor. And that works fine until it doesn't. So you would fetch an object, and because everything is Objective-C, it doesn't really crash right away until you access a property, and it's like, this thing is nil. And you're like, but it's not optional. How can it be nil? And then the reason is because you made it optional in your core data model editor. Too much wasted hours in that, I would say.
Yeah. Another thing that happened in iOS 10 that I also don't remember if you talked about is they actually added a bunch of genericized APIs for core data, like fetch requests that are typed with the result, so that you don't have to cast the result of a fetch request back to array of whatever your managed object subclass is. CacheResultsController itself got a generic type, and there are a few other things like that. Can you talk about those a little?
Sure. So what they did is, in the past, you would have, let's take a fetch request as an example. So in the past, you would have a fetch request, and you would tell it through, I believe it was with a string, actually, just to tell it, like, this is the name of the object I'm going to fetch. And they would pass it the predicate. So, like, fetch me all users with this predicate, where users would be a string. So it's very easy to make mistakes there. And also, once you would get the result you would want, you didn't have an array of users. I believe it was an array of any, actually. And you would have to cast that down into your array of users, which wasn't the nicest, swiftiest code to write. And then in iOS 10, they made everything generic. So you can now have an NSFetch request and tell it that the thing it's going to fetch is going to be a user object. So instead of giving it a string, you'll just give it, you'll specialize the fetch request with the user class. So once you get all the results in, you don't have to typecast them. And instead, you'll just have your array of users ready to go without any nasty casting from any to whatever you want. So it's a lot clearer and a lot less error prone, I would say.
Yeah, I think those are some pretty nice changes. They also made creating objects easier.
Yeah, for sure. Now you can just pass the managed object context as an initial, as an argument to the initializer for a managed object. And while that is nice, it's still not what I would personally love to see, because this is where you can see that core data really relies on the Objective-C build time. So when you initialize your, let's say, user object and you pass it the context, you don't have to initialize like any of its properties, even if those properties are non-optional, which can lead to very frustrating situations where you forget to set a variable and you won't notice it until you either access it or try to save your object to core data.
So I want to talk about one element that frequently gets thrown out there as a reason that people don't like core data. And it comes especially from people that have a so-called enterprise background. And it revolves around the concept of persistence ignorance. That's different than persistent ignorance, which I'm guilty of. But the idea is that you don't want the objects that you're using in your code to care anything about how they get stored. And if you're using core data, everything's an NS managed object, which violates that principle. So core data is typically invasive. It typically is all over your app, whether you want it to be or not. It's not alone with core data. If you're using Realm, you have the same type of problems. But in the world of Swift and structs, we want everyone using structs nowadays, which has no concept of how it's stored at all. How do you respond to that when you're trying to get people to rethink core data?
That's an interesting question. It really depends, in my opinion, on what you're using it for. Like if you're working on a small app with just a couple of entities, you're unlikely to ever want to move away from core data. If those are sort of your boundaries in which you're working, I don't think it's a big problem to have core data littered all through your code. What I have done in several projects is basically create a shadow struct for every managed object, which means that every object is defined twice, which is not the cleanest thing to do, but what you can do then is basically write a small little database layer where your NS managed objects live. And then as soon as you want to expose those to the outside world, you can convert them to structs, which means that they don't have any shared state between places. You can modify them if needed, and they won't accidentally modify anything in a different place. And then when you store them back, you just pass it to the database layer, and the database layer will figure out how this struct maps to an NS managed object. It's a lot of work to get that right. I do like it a lot because it really makes your whole app agnostic of where the objects are coming from. For all you know, it's different data stored, or it could be the network or anything. But it's a place where I would like to see Core Data adopt something like Codable, maybe, where you would be able to very easily specify an object as maybe storable or something like that. And Core Data would then just know how to handle it. And it's a matter of a protocol conformance instead of being so tightly integrated with managed objects. But like you said, it's the same situation, I think, for any persistent framework on iOS right now. You either go all in or you start writing some wrappers.
Yeah, I have to admit I've done that. I've done that solution, and not even necessarily with Core Data. Even Realm is very heavily tied to Objective-C and has some limitations on what can and can't be stored. And so I found myself writing structs that will convert to database layer structs and back, so that kind of hiding and encapsulating that layer, that database layer, for in case I ever do want to switch out Core Data for some other database solution. That's much less code that I have to rewrite. And now I've got a separation of layers, and I've got these objects that can be passed in and out and through the upper layers of the UI code, for instance, and not have to have those so tightly coupled to the database layer. So I agree with you. I think that's a great solution.
And speaking of defensive Core Data, Realm was just bought out, right?
Yeah, they were by
MongoDB, I think.
Okay, so they could be shut down if the venture capitalists don't think it's a worthwhile thing to keep going, whereas Apple, unlikely to shut down Core Data, or at least get a long sunset in. So there's some stability baked in.
Yeah, for sure. And also to come back a little bit to that, to encapsulating your data store, one benefit that I didn't expect to find when I was writing my wrapper around Core Data is that suddenly it was much easier to write tests for certain parts of my code, because I could just inject a fake database that didn't even persist anything and would just return structs instead of relying on Core Data or the network or anything. So that was a very nice little benefit, to kind of be able to drop your data store altogether and just return what you want to return in your tests.
Are you talking about setting up your mocks or whatever with like pure Swift structs, or are you actually?
Yeah.
Okay. So you're not.
Yeah. So let's say you have a view controller that uses a database layer to retrieve its objects for a view. And your unit test, you might want to drop the database and just give it back a predefined object to see if everything is set up correctly. So it's kind of nice.
No, that makes a lot of sense. And those are much easier to set up in your unit tests if you're just using pure Swift and structs, things like that. Another challenge I hear with using Core Data is that it's hard to write unit tests, especially if everything's an NS managed object. How do you write unit tests?
It's actually really, I'm scared to say it, but it's quite simple, because you don't have to persist everything. You can use an in-memory store, which means that every time you make a new instance of your Core Data stack, it will just live in memory. So you can easily just have like tons of scratchpad empty new databases. And from there you can just create your managed objects as you would normally do. So it's really not that big a deal once you get the hang of it, I would say.
Okay, that makes sense. That's the approach I've heard in the past. And Aaron Douglas has been on the show years ago. Was the first person I heard talk about that. It's been probably 4 or 5 years since I've heard him say that, but that makes sense. So the same type of things you do with, you said in your coordinator, like anything else, it's just going into memory and not being saved to a disk.
Yeah, that's what I would do if I want to test whether some object can be converted to a managed object and whether it is then actually persisted in core data. Like if that is my purpose for a test, I will use an in-memory store and go with it. If I just want to test if like some object is attempting to talk to a database layer or is attempting to get data from a database layer, I will often just try to pull core data out of the equation entirely and use a protocol like to hide the fact that it's core data and then return structs from there.
All right, very cool.
We're getting low on time. Is there anything we haven't talked about that you think we definitely should before we finish up?
Oh gosh, I don't really think so. Like, there's tons of stuff to talk about, but I do think one interesting thing to call out is that a lot of people seem to want to think about core data as a layer on top of SQLite. So they start thinking in terms of primary keys or certain ways of shaping relationships, which can lead to a lot of problems down the line because core data is just not intended to be used like that. But at the same time, you can and should actually use compiler arguments to turn on SQLite debugging, so you can see like what SQL statements is core data generating for me, and are they sensible? Like, do I need to optimize something? And then take action accordingly. Like, for instance, telling core data to, if I do this fetch request, always fetch these other entities in the same SQL query because I'm going to need them anyway, which is a nice optimization that, in my opinion, is good to know about and good to keep an eye out for to see if that is going to drastically reduce the amount of time spent getting data out of SQLite.
That's a good tip. When I'm talking to people, I always have not used core data or new to core data, specifically when I'm teaching. I make it a point to say that SQLite is the default and by far the most common backing store for core data, but it's not the only option. And you can actually write your own backend if you want. So don't think of it as just a wrapper around SQLite because it's literally not. But it does get used that way most of the time, and so turning on that logging is helpful. And there actually now are some features in core data that only work if you're using the SQLite backend, which I think is a little bit, I don't know, philosophically that kind of bugs me, but it's reality, and so there's a balance there.
Yeah, it always feels a little bit counterintuitive to first tell somebody to not think of core data as a wraparound SQLite and then tell them to turn on SQLite debugging. Always a bit of a weird contradiction.
Right. All right. Well, if there's nothing else, let's get to our picks. Donny, do you have any picks for us?
This is the part where I get to shamelessly self-promote something, right?
Absolutely.
Nice. So then I really just want to promote Disney Plus, Disney's great new streaming service that I kind of write code for with the SDK that I built. So definitely check out DisneyPlus.com. And also check out Disney's career board because we are hiring iOS developers. So those would be my two picks.
I was going to say I didn't know you had launched, but you have not launched yet, right?
We have not. I believe our countdown on the Disney Plus website says November 12th now. So keep an eye out on that countdown.
And where is your office located? Do you have to work where you are, or is it anywhere?
So we have an office in New York, we have one in San Francisco, and we have one in Amsterdam. And I believe there's some outposts in the UK. There's a couple of remote people. So we are basically all across the globe right now, except for in Asia. I don't think we have anything on the ground there yet.
Can I just say how weird it is that the Simpsons are Disney characters now?
I know, right?
Great. Thanks for the pick. I'm actually kind of excited for Disney Plus. I think it's going to be a good streaming service just because Disney has so much stuff that people want to watch. Mike, do you have any picks for us?
Yeah. So kind of in the same vein as talking about core data and well, any database layer that you end up writing, you have to write a bunch of boilerplate code for connecting things and such. Especially if you do, like we talked about, encapsulating and basically writing a duplicate non-core data instance or entity that is going to be very, very close to the same thing as what you've got in that exists in core data. I found a really cool templating project. I'm not sure what to call it. Anyway, it's called Sorcery, and it uses a language called Stencil to help generate Swift code. And actually, recently they've updated it so that you can actually write Swift now to help have it generate Swift code. And it's pretty cool. I'll make sure the link gets posted in there for it. But it's open source. You can install it using Brew, and very handy for generating code based on other code. I could spend several hours talking about that just in itself. We can have another session on that. But yeah, I'd highly recommend it. I've used it for a number of projects, including dealing with core data as well as with Realm. Found it very useful.
So I think that tool is by JP Samard, who's been on the show. It was probably a few years ago, but we talk about it a little bit. So if anyone wants to learn more about it, check out the archives.
Sorcery is actually not by JP. Maybe he's working on it now. It's by, I don't know how you say his name because unfortunately I don't pronounce Polish. I think he's Polish. Krzysztof Sobłocki. That's the best I can do. And he's a super, super smart guy. He also made before Sorcery, he made a Objective-C Playgrounds, which was cool.
Okay, I stand corrected. JP used Source Kitten, which is based on Sorcery, but also cool. And in the archives.
Yeah, that's right. JP is Source Kitten. Great. Thanks, Mike. Jaim, you said you want us to skip you?
Yep, I'm pickless today.
Okay. All right. So I have one pick, and my pick is actually a hardware-related pick. I've been doing some hardware design again recently, and that is Eagle PCB, which is if you've done any hardware design, specifically printed circuit board design, you probably already know about it. It was acquired by Autodesk a couple of years ago. I was pretty worried about that acquisition, but they've actually made it significantly better, and I'm very happy with it. It is by far the cheapest way to get into printed circuit board design. So if you want to, even just start dabbling with hardware and design your own circuit boards, Eagle, well, I won't say it makes it dead simple to do. It makes it much more approachable than it has been in the past because you don't have to pay thousands of dollars, and there's just a wealth of YouTube tutorials, et cetera, about how to use it and a huge community around it. So that's my pick, Eagle PCB. All right. Thanks so much for coming on the show, Donny. If people want to, get in touch with you, what's the best way to find you?
Probably just find me on Twitter.
And how can one do that? We'll put a link in the show notes, but
twitter.com/Donny Wals. Couldn't be more simple.
Okay. And Wals is WALS. So like Walls, but only with only one L.
Yes.
We will put a link to your talk at Try Swift in the show notes. And with that, thanks for being on, and we'll see everyone next week.
Thanks for having me.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit